Hi there, my name's Natalie Roberts and I am the Outreach Officer for Aberystwyth University's Faculty of Business and Physical Sciences. Today I'm here to talk to you about the benefits of 3D printing for coronavirus and other applications. But before I went straight into the applications, I wanted a chance to quickly touch on a brief history of 3D printing. It might surprise some of you that the very first account of 3D printing actually dates back nearly 40 years to 1981. Since then, the technology has come on in leaps and bounds. The very first 3D printers that were used in manufacturing were photopolymer liquid-based 3D printers. There's an image of a more recent one here, where you have the tank of the photopolymer, that is a liquid plastic that reacts to light, and a 3D model being lifted out of it has been produced by using UV lasers targeted at the correct areas of the liquid polymer. The next type of 3D printer that then appeared, which was in 1992, was one that produced these sort of models. Now what it used, instead of the liquid photopolymers, it used this dust that we can see around the bottom of the tray here to produce the model parts. And then after retrieval from the dust, they would then have to be post-processed to make them a nice clean plastic model. As you can see, it would have been quite a messy process. And although these were the very first printer to be made commercially available, they didn't really take off. So what did start the boom in 3D printing and the ability to do it at home, in school, and in the office? Well, it was the introduction of this style of 3D printer. It's called filament-based. This is a sort that you're more likely to see around, and it's the one that you probably saw in our advertising posters. It's the one that we have, it's the one that we've used at the university. What it is it builds up a model layer by layer by heating up a plastic filament and melting it into a certain design pattern, one layer at a time. Now this suddenly reduced the cost of having a 3D printer, reduced the cost of the materials, reduced the mess, and it reduced the post-processing time. So now we have a more readily available model. Most schools, most of the secondary schools in our county now have at least one of these on their premises. The university has several across its departments, and some of us also have them at home. Now the interesting next stage is there's now a new wave of 3D printers appearing on the market that you can use at home. These are called resin-based 3D printers. Here we are. Now I would not be surprised if you start to see the resemblance to the very first 3D printer I showed you. It works on exactly the same principles. Although it's called a resin-based, the resin is liquid form and it's photopolymer. So we've kind of gone full loop, but they're now making smaller, more cheaper units that can now be used at home. A little bit more on those ones later. Now in the meantime, although most of these are all focusing on plastic, other industries were taking interest in this new 3D printing technology. For example, the medical profession. They developed the 3D printing techniques, but instead of using plastics, they replaced the plastic filament style with bioinks. Now these are just ink, well, they're called inks, they're liquids made up of stem cells. And you can take stem cells from anyone who you're producing the organ for, meaning that there's less chance of rejection for the organ during implant. So here we have an image here of an ear that's been printed using said bioinks. Another industry that has also taken up 3D printing is actually the culinary profession, especially with the invention of this one. This is a chocolate printer. The uptake maybe not as high as you'd expect because of the costs involved, but still a lot of fun. And I think the main thing to look at is the fact that they are starting to print in food, and it's now being used as a basis to start research on what other foodstuffs we can print with, and whether we are starting to take that first step towards our sci-fi style food replicators that we see in TV series like Star Trek. And there ends our brief history of 3D printing. Next, we'll go on to the main focus of tonight's talk, which is how we can use 3D printing for combating coronavirus 19. Now, for us at the Aberystwyth University, we had a small team of us ended up involved in producing face shields for health workers out in our community. Now, how did this all come about starting? Well, we were contacted, or rather the department was contacted after lockdown had started, by a district nurse who was hoping to get hold of some form of face shields. She'd seen online about a news article about another 3D printer owner who had been printing these face shields for his local authorities. So she contacted our department. Unfortunately, due to lockdown, there was no one left really in department to be able to help. But we were fortunate that a couple of us had 3D printers in our homes. So having received the message and having it forwarded to me, I started to do a lot of research, and I went online and we looked for the design that she had referred to, which unfortunately was a news article that didn't actually tell us what design the person was using. So we had to do a little bit more investigating. Now, just to show you just how difficult such things are, I'm going to see if I can get this to actually load up here. Here we go. This is called Thingiverse. It is a repository of freely available 3D designs. Now, this is just a basic search for COVID-19 face shields, for shields. And as you can see, there are a whole range of different face shields available. Okay, so hopefully, go back here. So how did we choose one? Well, we did some investigating, and the one that seemed to come up most with the best ratings from other people involved in the community effort, the 3D printing community effort to help health workers across the UK and the world, was this one. It's Prusa. If you noticed in the very start in the advertising pictures that we have of that face band, it had Prusa actually engraved in the side of it. Now, Prusa, the reason we chose their design, which has evolved again since, as it's been trying to meet all the requirements necessary to be passed as suitable for healthcare work. They were putting in patents around the world to actually get their design patented and certified for use within various health services. So we had a look and we decided that yes, we could do something, and we used this very similar design. How did we produce them? And I have a video here to show how we put them all together. Okay. So in this little video, I'm just going to show you how easy it was to put these together once printed. So this is one of the headbands for the coronavirus face mask that we chose. This is how it looks straight off the printer. And if you notice, there are some loose bits on there that need to be cleaned off before we can use it. But there's also this flat bit here. This is called a raft. I will mention it again in a later video about the Beebug 3D printer. Now, the reason we use these rafts is because if there's going to be any deformation to the print, the chances are it's most likely to happen when it starts. So if I can get this in the light enough, you can see there's some deformation of the plastic on that initial couple of layers that's made the raft. So by printing this bit, we've protected the main print. And then once it's done, you can literally just snap it clean off. And you've got a nice clean surface for the actual print. So what we did was we did that for each of these and then cleaned them up. So this is one that I've already cleaned up a bit, so it's ready to be demonstrated on how to actually finish prepping one of these face shields. So you'll see here there are 4 little knobbly bits around the headband, and then these 2 attachments at the back. So what you need next is something we can attach as an actual face shield. Now, due to limitations of being home produced and due to limitations not being able to get hold of the goods at the beginning of the coronavirus outbreak due to essential shopping only, we decided to do some investigating, and we had some of these lying around. Not everyone will recognise what one of these is. These are called laminating pouches. So what you do is you put your A4 paper in there, your worksheet or your presentation, and then you put it through a heater, a laminator, to give you that nice sealed, shiny effect that protects the paper. So what we did was, rather than putting the paper in, we just put it through the laminator.
Right. There
we go. So it goes from this opaque plastic through to nice, easy to see through screen. Okay. So now it's heated, it's much more rigid than it was in its non-heated state. It's also pretty see-through. Obviously, me doing this today, I'm not doing this in a sterile environment, hence the bits of fur I keep pulling off. I'm also not wearing gloves today, or a face mask. So, if you notice, I've already put some holes in here. Now what I had to do was just mark the centre point, and then mark on each of, you see those little black marks? That's just wipeable black marker pen that wipes straight off and can be cleaned off easily. To mark on where those two ones are. Then using just a standard 2-hole punch, gone 2 here and 2 here, and then we just click it all into place. So, like so. So there we have it. We now have a basic face shield. This screen, because of the laminated plastic, you can wipe it down with most cleaners. Most detergents, most cleaners are safe to be used on this screen. The band itself, as I already mentioned with the plastic that we use, can be soaked in soft detergents such as an antibacterial washing up liquid overnight. They are not designed for surgical wear or medical purposes directly, but they are an extra line of defence for your social carers. Now the one thing that's still missing is this here. What we did was we took strips of elastic. This one's all nicely marked out. This was our template piece. So we've got a piece here where we've just used a scalpel to slice a hole. And then we've got different settings down here depending on the size of head. So all you do then is put it onto that one onto the side, and then the user can adjust it to whichever of these that they wish to use. If they also wish, they can trim it down. And there we have a fully wearable face mask. Okay, so now hopefully you've seen the very easy nature of how these things work. The next problem, of course, was we were in lockdown, so how could we distribute these to the people who needed them? We were very fortunate that a lot of our requests were coming from district nurses or from people who had, or companies that had staff that would be passing by on their way to and from work. Therefore, distribution was made easier by the fact that we could leave the face shields all sterile and ready to go, or as clean as we could make them in our household, ready to go in a food ready container that was placed on a covered porch outside. They were placed out there with about 20 minutes before they were due to be picked up to avoid contact with the health workers. And on occasion, we actually did exchanges as well, where they would leave something like, I think one group left as face masks, as in the material face masks in replacement for the face shields that they had made themselves. We also use this method to retrieve materials from our local community. So it was going really well, and it got picked up by our press team at the university, and it was published in the Cambrian News. That's when it all took off. Suddenly we had requests coming in from all over the county and from some places outside of our county, mostly from care homes where they just were feeling like they weren't being supplied with the necessary equipment fast enough. And although we explained the limitations of these face shields and the fact that they were not authorised by the local health board to be used as coronavirus defence systems, they would much rather have some form of protection than none at all. So I think we ended up with requests for over 1,000 at one point alone. Now we were running just one printer, and we could only print 4 a day because of their style of printer, which we'll go on to a bit later. But we knew that there were several printers sitting at work unused. So we got together with the physics technician, Stephen Fern, and, well, didn't get together, online got together, and he managed to get permission to go and retrieve the additional printers. So here we have his setup. He had 3 Ultimakers that he took home with him he picked them up from the university department, brought them home, and managed to get all 3 running at the same time. It meant that they could produce a lot more during the day than we could. Plus, with it being Ultimaker printers, they were much faster and more reliable for their prints. Again, something we'll look at as we start to look at how to consider buying a 3D printer. So we have here 3 Ultimakers all running separately. And we were soon able to meet all the demand that we had until demand just dried up because the true face shields, the ones that lived up to the NHS's specifications and stuff, started to become more regularly available to the services, and they were back on track for not needing the backup replacements. I do have here a little video that Thomas Fern provided me with, which shows the 3D printers at work producing the headbands for these face shields. You see, they've got 3 going at the same time. Okay, so what else could we use it for? Well, on the left here, you can see these white random shapes going on this side here. These are prototypes that were 3D printed. Again, this is thanks to Stephen Fern and Thomas Fern. They've printed these prototypes for devices that can be used to open doors around the university without having to use hands, to try and avoid that surface contact that could help spread the contagion once we start to work around the university again. However, due to the slowness of production on a 3D printer, it was decided that the 3D printed version, although it would work, is not as easy to clean, not as easy to maintain between uses, with it being made from, again, PLA. So using this prototype and testing it, they chose the one on the top here as the most suitable design that worked for most of the doors around the departments, and started to use that design and cut it out of 10mm acrylic sheeting in the workshop at the university. They're planning to produce at least 700 of these to be able to distribute them amongst the staff members around the department who will need access to rooms with door handles. I mean, they're not the first to come up with that idea. In fact, I did a quick little search again on my favorite repository, which is called Thingiverse, and found lots of different renditions of the door opener devices. You've got one very similar to the ones that Steve and Thomas have been printing and creating. Then you've got ones that are more familiar. They look like the door handles, ones that are designed to do multiple different types of door handles, ones that are designed to do door handles and lift buttons. And this one, I think this one's probably my favorite, the one that's designed to turn any door handle into an arm use handle to avoid hand contact. So it's material contact only. What else have they been used for? Well, as you can start to imagine, there's a lot of things we can do with 3D printing now. So some people have had problems with the whole new face mask restrictions that are starting to appear, and the advice to wear face masks whenever in an enclosed space with other people. And I know myself that I find a problem finding face masks that fit without being either pulling too tight on my ears or being too loose on my ears. So there is this here. These are called ear protectors, or straps for face masks, or I don't think they actually have an official name. What they do is they hold the face mask around the back. These take like 20 minutes to print quite easily on a domestic 3D printer, and they come in a variety of different designs. And now I'll show you a little video just to show just how these simple little things work. Okay, so now you can see that this mask is much tighter, it's much better fit. And the reason is, this here, you can set it onto whichever setting you need to make the straps more comfortable. It takes some of the pressure off your ears to the point of you can even take it off your ears if you wear glasses like I normally do. It makes it more comfortable, holds it in place for the entirety of your shopping trip or whatever it is you're doing whilst wearing the mask. Okay, so for a quick solution, if you've got hold of face masks or material or made your own face masks, all you need then is something maybe like this to help hold them in place. However, if you've got a bit more time and a bit more patience, you could always just make your own face mask. 3D print your own face masks. The advantages are you can customize them and make yourself have really cool looking face masks, or you can customize them to fit your face and your face only. Or you could go absolutely crazy and have a multiple part face mask. The only disadvantage of 3D printing a face mask though is that you can't print the filters. The filters have to be provided on top of the print. I mean, this one here recommends using a makeup pad as a replacement for the actual filter. Others, when you start to look in the design specs, recommend that you get hold of the correct filters for avoiding small particle absorption. So 3D printing opens up this whole new avenue of different ways that the community that own them can help others around. I mean, thankfully, we're now stepping away from the PPE crisis. So there's not been as much call now on the community for producing these. I mean, there are still some running, making the easier, more basic ones for shopkeepers, shop assistants, or other people who just want that little extra layer of protection. They may not be suitable for things that are small, tiny droplets, but they're good for stopping your major water droplets. They're good for stopping you from touching your face without thinking about it. So that just about covers what 3D printing, some of the uses that 3D printers have been put to for coronavirus. Now I'd like to have a quick look at some other applications for 3D printers. Now, to start with in this section, why did we even have 3D printers available for this? I mean, what were we using 3D printers for? Near the beginning of this talk, I mentioned, well, at the beginning of the last section, I mentioned that some of us were fortunate enough to have a 3D printer at home. Now, in our case, it's because, basically, I'm a woodworker. I like working with wood. I like working with my hands, but my partner does not like sawdust in the house. So when it's bad weather, I can't do my woodwork. So as a replacement, we've picked up a 3D printer. After a lot of research and a lot of time, we picked up a 3D printer to give me something to put my creativity to use to. And this is where a little bit of geekiness is going to come out, because this is what I use my 3D printer for normally. You can see here, these are tabletop gaming pieces. We're building our own version of a really old original tabletop game. So that's kind of why we had it. It was more out of intrigue and interest and the art and craft side of 3D printing. So how come the university had access to 3D printers? Well, the answer is the departments of physics and computer science quite often need prototypes. And these prototypes can often be generally better created in plastics. Now, rather than laser cutting or trying to put something together in the workshop or sending it off to a company to have it 3D printed at a charge, we decided to invest in a couple of 3D printers. Now, they have been used for research, they've been used for hobby crafts, and they have been used by the Aberystwyth Robotics Club. Here we have two examples of how the 3D printers within our department have been used prior to the coronavirus outbreak. So on the left here, we have what's called the InMove Android robot. This is available open source to be printed in parts with instructions for how to connect and wire and program each of the separate sections. Okay, in that picture, you can see the two young lads who were involved in that project. On the right, we have a replica of a Scudder robot from the Red Dwarf TV series created by one of our Advanced Robotics Club members. In this case, the entire outer shell, all the blue here that you see, was designed and then printed using the 3D printers available within the university. So that pretty much sums up why we have the printers. Next is this the first time a 3D printing community has formed? And the answer is no. Although it's hit a lot of press recently with all these different people using the same designs or very similar designs to produce face shields across the whole of the UK and in fact the world, it's not the first time that the 3D printing community has come together. I think my favourite story of a community project that I'd like to share with you was from this gentleman who bought a 3D printer and learned how to make bionic limbs, specifically arms, because the NHS cannot cater for children who are missing limbs. Due to the speed at which they grow, these artificial limbs have to be replaced regularly. So he looked at how he could design ones that were easy to modify, easy to produce, not expensive, not going to be clunky or chunky. And in fact, they operate, as you can see in these pictures, they are very well operated replacement limbs. In fact, it has now grown. His work has risen with such regard within the community. Not only do others offer their assistance with printing them when there's a backlog of orders for their children, but as you can see from the designs in this image, Disney has given permission for him to use their designs to create some of the patterns for the kids. So you can probably identify in this image, you've got their design from Iron Man, a design of BB-8 from Star Wars, and then you've got the Frozen design. So this is one that I really find this an absolutely wonderful usage of 3D printing technology. He started it in a shed and now has become an international business, providing children around the world with the opportunity to continue living life as children. Other community projects aren't quite the same. I mean, this is one that I find quite fascinating. Now, they can't obviously get home printers to help with this project because it's building buildings using concrete-based 3D printer technology. The idea being that we could produce a concrete building that is suitable for habitation in less than 24 hours using 3D printer technology. This is a community project because it's done by charities. They fundraise. The community aspect is a fundraising to get these together. And a lot of countries are starting to look at these as solutions either for quick building or just to replace the buildings in shanty towns with something a little bit more stable that will reduce risk of life when there's an earthquake or any other issue within the community. So no, coronavirus has not prompted the first ever 3D printer community get together. So now I'd like to have a look at commercial 3D printers, because after this talk, I'm hoping some of you might be a bit more interested in looking at what you can do with a 3D printer. I mean, we've just touched on a couple of little projects that are going on. So what do you need to consider if you are looking to get a commercial 3D printer? Whether it's for your business or for personal use, or maybe you know someone who might benefit from one. What do you need to consider? Well, point one is what type do you get? And the reason I asked this, and I did mention this earlier, that we would get to resin printers. Most printers on the market at the moment, and the ones that we use for the coronavirus face shields, were filament-based printers. They use different plastic filaments and print layer by layer. But we are now starting to see a new type of 3D printer appearing on the market, and it's resin-based. So it's almost back to that original design of having a liquid tank with UV light beams, but instead of using a photopolymer plastic, it's using a type of resin that has a similar reaction. So which one do you get? What is it you want to do? Well, the benefits of the resin printer that's now appearing on the scene is that generally the average price is cheaper. It produces a much smoother detail and is much more suitable for high detailed small models. The problem with it though, or rather the disadvantages over filament, is that there's a lot of post-processing involved with resin models. Not only is there post-processing involved, but this post-processing involves various irritants. The resin itself, before it is cured, is an irritant. The alcohol cleaners you need to use after it's been printed are irritant. And it can take days for it to fully cure in natural UV light from the sun. So quite often users resort to buying additional machine for cleaning, or possibly even additional machine for cleaning and UV, or separate. So the cost starts to rack up. It also actually takes longer than a filament printer would for this style of design, not just because of what you have to do after the model's printed, but for print time itself. And the other negative is they are quite small. So their build plate size is smaller, so you can't build such big models on them. So it does depend on what it is you're planning to use them for. I mean, if you are going to use it simply for high detailed, really fiddly small models, then yes, you probably want to look at the resin option first, but bear in mind the additional costs that are hidden by the fact that you have all the post-processing. Plus, resin is generally, weight for weight, more expensive than filament. So let's look at the filament printers. As I've already said, the materials are cheaper for filaments, or rather there are cheaper alternatives available depending on the plastics you're looking to print with. The material is easier to change. You don't have to empty a tank to change the colour of your filament. You just change the reel over. There's more choice of different materials. With resin, it's just transparent or solid, and the different colours. Whereas with filament, you have an option of colours, transparency levels, but also what type of plastic they are. And you've got larger build plates are available. You've got larger size printers that can do larger builds depending on what you need them for. So that's the first thing to consider. Right, so next thing to consider is the bed size versus space availability. Now, I've already mentioned about the building plate. It's often called the bed. So when we talk about bed size, we're talking about just how big a model you can build on it. So depending on what you're using it for, you probably have an idea as to the maximum size plate that you need. Now, the most obvious thing is the build plate will help determine the amount of space the printer will take up, because the majority of the printer size is the build plate. The rest of the width and depth of the unit is made up by the size of the head unit, which is your nozzles. So what's next? Now is your temperature range in your materials. Now for this one, what I've done is I'm only looking at the filament printers. The reason being that resin is all working at one temperature and there is only the one material, the resin. So this is focusing on your filament printers. I've just chosen here a few different plastics to go through that you can use in a 3D printer, their benefits, but also the temperatures they require. 3D printers come in a whole range of different types and styles and makes. And the temperature the nozzles can get to can determine which plastics they can and can't print in. So the most commonly used plastic is the PLA, which you've probably heard me say a couple of times today. It is a plastic that is recyclable. It can be degraded, it's chemically degraded. It is also the cheapest one out there and probably the easiest one to print with. It requires some of the lowest temperatures. In fact, from the ones that I've chosen, it is the lowest temperature filament. You can print with it from anything between 190 and 230 degrees centigrade. The next one I've got on my list is ABS plastic. Now this is much stronger, it's more flexible, and it's got some shock resistance in comparison to PLA. However, it is harder to print with, and it requires a much hotter nozzle temperature and bed temperature. So as you can see here, it's a slightly higher range of temperatures, 210 to 240 degrees. ASA, that's very similar to ABS, except it's more resistant to UV light, so it's more suitable for objects that will be outside or in windowsills for long periods of times. Now, this one requires about 260 degrees C ability from the nozzles. Not only that, but you also have to take into account that whilst working with this plastic, your printer will produce toxic fumes, so it needs to be well ventilated. Not so suitable for the home office, for example. PET is probably a more better known plastic. You've probably seen it on containers as PETG, that's one version of it. Fully recyclable, food safe plastic with some flexibility to it once it's finished printing. Now for that, you need to be able to print between 230 and 250 degrees centigrade. Polycarbonate is another one I've put on the list. This one is a little bit harder. It's got really quite high heat resistance and quite high strength for a plastic, which is what makes it favorable amongst a lot of businesses. However, you need a very low humidity environment. You have to have no humidity in the background at all for it. And it requires temperatures between 250 and 320 degrees centigrade. This is out of the range of most commercially available printers. Then I have listed the high performance polymers. Now there's a whole range of these. I have put them on there just to show just how higher temperature is required from some of the heavier industry machines for 3D printing. These require 420 degrees centigrade and more, depending on which one you've chosen to use. They are pretty fantastic in regards to their materials once they've finished printing, once they've all finished cooling. They are on par with metals for their resistances, but they are lighter in weight than metal, meaning that they are perfect for aerospace, automotive, and medical industries. So, I mean, that gives you an idea, you know, it's not just about what it is you want to print. You need to think about the materials you're printing with and take those into account when you're looking at buying a 3D printer. Number of extruders. Now, unlike a color printer where you have inks, as in a standard 2D printer, you can't mix any color from 4 different colors. If you want to print something that is multiple colored plastic, you generally have to keep changing which plastic you're using. So if you have a single nozzle, what's called a single nozzle or a single extruder printer, which most 3D printers are, when you want to change the color, you've actually got to manually change the filament over partway through a print, which can cause its own problems, especially as different colors of filament can sometimes require slightly different needs from the temperatures of the building plate or even the nozzles. So you can now start to get blending extruders where it's still one nozzle, but it will take feeds in from multiple different colored filaments and automatically change over between them or even blend them together. You can also get printers that are called dual extruders, which means that they have 2 nozzles. They can print in 2 colors at the same time. So you need to work out, are you printing things to paint? Are you printing things that you want to use 2 different types of material for? For example, there is a PVA style filament you can get, which provides support for whatever you're printing that can be washed off afterwards. So do you want to be able to print in that whilst also printing in the plastic without having to change materials and printing things on each layer? Next thing to consider is out-of-the-box operation. What I mean by this is, can you take it out of the box and use it quickly? And the answer for most 3D printers is unfortunately no. When it comes to the resin printers, they claim to be up and ready and you can print your first model within 5 minutes of opening the box. Now, I can't vouch for that. I've not actually got a resin printer, so I don't know just how simple they are to set up, but they are just simply a tank, a shield frame, and a build plate that need to be assembled, ready to go. 3D printers, the only one I know that you can pretty much take out the box and use straight away is the Ultimaker range. Others tend to involve quite a bit of construction, putting them together, and a lot of adjustment. You know, you need to calibrate everything for the surface that you've put it on, for the room it's in, for what materials you're using. You've got to make sure the bed plate is level to the head, to the nozzles. You've got to make sure there's enough gap. You've got to make sure your fans are the right temperature. You've got to make sure the room is dry enough. There are lots of factors at play. Now, I don't want to put people off buying a 3D printer because of this fiddly aspect of getting it just right. There are a lot of support groups online for these things. I mean, one of the first things we did after we purchased our Beebug printer, which I will introduce you to shortly, is the fact that their communities on Facebook will help you with anything. So we instantly joined the Beaver community Facebook page, and anyone who has a problem or a question or just want to run something past people, they are more than happy to help each other out. You know, we're back to 3D printing communities again. And it's the same for all the other makes, Ender, Prusa, Ultimaker. They all have their own communities online, whether it's through Facebook or through 3D design repositories. I think Thingiverse has community groups for each of the different printer groups. So the next thing, and probably one of the more important things, is what is your budget? How much are you willing to pay for what it is that you want to do with your 3D printer? So here we have what was, at the time that I made this presentation a couple of days ago, the cheapest 3D printer I could find on Amazon. It's just shy of that £120 mark. It is very basic. It is a single extruder nozzle. It can only do 1 plastic at a time. It can't even take the full plastic reel. You actually have to take the filament off its reel to hang it on here. You can see here, this is the build plate, which gives your left to right movement for your build, and the head moves up and down. The actual control box is separate to one side, so that means it instantly takes up a bit more space. So this is the sort of thing you're looking at a really budget end. Next one that I looked at was this one. Now this one looks very different, and if you notice, the build plate is at the top. That should tell you what sort of printer this is. This is one of the new resin printers by Elegoo. Now this one will set you back £220. And it is just the printer. It won't do any of the curing. You have to do all the post-processing of the resin once it's finished printing. So yeah, that's just to give you an idea. This is probably about average for the price of these machines that I was finding for the resin printers. You are, however, if you want to buy the machine that does the cleaning and curing of the models after the print, looking at doubling that price and the amount of space it needs to take up on your desk. So the next one I'm going to go to is actually the Beebug. This is the printer I currently have here, and I will shortly take you for a tour of. So Beebug here is 530. If you notice, it is quite a big machine. The reason the build plate seems so small in comparison to the rest is you have the build plate, but you also need space on this XY axis for the two extruder heads here to be able to slide in without being in contact with the plate. I mean, you'll see this more when we do the little tour of the machine. You'll also notice something slightly different. This one has a red shield. Now the resin printer had that orange shield, and the reason for that is because of the UV light it's using to protect us. But if this is a filament-based printer, why does it need a red shield? Now the reason for this red shield here is that it has a little twist to it. Not only is it a dual extruder, but this whole unit here can be taken out and exchanged for a laser unit which allows for wood engraving. So laser engraving of wood is possible with this machine. So because of the lasers, you get provided with the red hood that goes over the top, and also you get provided with the red safety specs to protect your eyes when you're using it for that purpose. I haven't yet actually tried that out on mine because I spent so long getting the settings perfect for the 3D printing that I daren't take it apart and switch the head over in case I lose that really nice calibration I've got. So it's something for the future for me to do, I think. Next time I have to do some tinkering. In fact, I'm going to stop now to do my little tour of Beaver. Okay, so this is my Beaver. This is about, well, it's over two years old now, this printer is. As you can see, this is how it all comes together once you've put it together. Unfortunately, this one does come quite flat packed to help protect it during the journey. So you'll see here we've got the red dome on, which, as I explained in the presentation, is because this one also comes with the ability to fit a laser head on for wood engraving. So if we take this off, you will see that we have had to make some modifications. If you notice, there's a lot of glue in around the edging here. That's because we have cats. Okay, so Beebo here is a fully openable door, which is why we've got this stuck to it to remind us when it's closed. The other things we like about Beebo is it does have a dual head, so it's got two separate nozzles down here rather than one. Do you want to come in so you can see the two nozzles if you can? I open the door. So it's got two nozzles here that will extrude the plastic to make the models, so you can have two different colours going, or you can have a PVA plastic to use as a scaffolding for your main print. So from the two nozzles, we can see up here, this is where the filament actually comes in. At the moment I've only actually got one filament currently fed into one of the extruders. You see here, there's the second one. At the moment I've got a black in here and I've got a purple, which I just haven't actually fed through yet. These connect to some reels at the back. Now these reels, I believe, are kilogram reels. So if I spin it round, you can see the reels of plastic here. So there's the black, there's the purple. You'll see they feed up here. And if I take this off momentarily, you can see the manual switches here. These are little alarm switches. So if your filament runs out or breaks, once that stops pressing down, putting pressure on those switches, an alarm will sound to let you know that you need to deal with it. So turn it back again. The other thing that's really quite impressive about this particular 3D printer is the printing bed. I'm just going to grab my spare one, which is over here. It's actually made from glass, which is supposed to help with adhesion. However, if you're playing a lot with high detailed models or models that you cannot afford to have any slippage of, what we do to avoid it is we use a combination of everyday masking tape. This one needs replacing because it's starting to get bubbles in, so at some point I'll be retaping this. Masking tape, and then on top of the masking tape for extra adhesion. So on top of the masking tape we then just put basic Yoo-hoo glue stick. So this is my little equipment down here. It's just basic decorating masking tape and a glue stick. So I put that back in. It's easy to take in and out, she says. There we go. So on this particular model, you'll see that it's the bed. The bed will move up and down as you're printing your models on it. But the actual print head can move both left to right, and if you look at the tracks, you'll see it also moves forward and back. Okay, you'll also notice this is actually quite a big printer for space it's taking up. The bed seems quite small in comparison to the size of the overall thing. That's because if you notice, when this is in its home place, on its nice mechanical switch here, it is clear then of the bed. So the nozzles, it's not going to leak any plastic onto the bed when it's not in use. So I'll put that away. It's easy to switch over your filaments. You just heat the nozzles and pull them through. The power switch is actually on the back, maybe the one design flaw. And when operating, it doesn't just, it all lights up, gives you a nice clear view of what's going on. There we go. Put the lid back on. So now you can see it's got its own internal lighting, so even in night time you can see if you've left it on because it lights up the room for you. It's also letting you know the power's getting to it okay. So once it's all lit up, you can hear, I don't know if you can hear it on the video, but the fans are already starting to whir on it. All the operations are down here on this lovely little touchscreen monitor down here. It allows me to set various things. Okay, so now you've probably seen just how much I absolutely adore my 3D printer. Let us move on to the creme de la creme of 3D printers. This is the Ultimaker 2 Plus. It is actually the lowest model that is currently available brand new from Ultimaker. That price is for this model, not the most up to date. I mean, we are talking about prices up to £5,000–6,000 to get the bigger, more up to date hardware. So the Ultimaker at £2,214 is your start price for that particular brand. You are paying for the fact that it pretty much works straight out of the box with minimal of actual fiddling or calibration. So hopefully now you have an idea. You are paying for the budget range. You are also paying a better idea of what it is that you need to be looking for if you want to buy one of these. So what's next? Now this is something I added to this: the ability to replace parts and the ability to actually upgrade parts of the machine. What I mean by this is, how easy is it if there's something goes wrong with the machine to replace a part? How easy is it to get hold of the parts? How much will it cost? Now, this is the one thing I find the Beaver has over the Ultimaker. The Beaver was manufactured, and as I showed you in the video, it's very mechanical. It's all mechanical switches, quite a simplistic operation that minimizes the things that can go wrong, but also maximizes the ability to repair them when they do. The parts for the Beaver are easy to get hold of. We're talking pennies per nozzle. We're talking, I think the most expensive part to replace is probably the glass plate that you print on, because it's a very specific size. When it comes to the Ultimaker, however, to replace parts on that, it suddenly becomes more expensive, because rather than using parts readily available, they've used their own custom parts, meaning you're very restricted on where you can buy them from. So as another thing to look at, and as for upgrades, I mean, you can upgrade fans, you know, if you're trying to use it in a room that's not quite suitable, maybe it's too high a heat in the surrounding air, maybe you might need to upgrade the fan units. It's really easy to do with quite a few of these printers, including the Beebug, but a bit harder to do these modifications to more condensed units such as the Ultimaker. So there ends my talk for today. Thank you so much for listening to me. And if you are interested in any more information about 3D printing and possibly even the 3D designing behind the models that we print, please come and visit my outreach hub. This link here will take you to the computer science page, but there are links also to the other departments within the faculty. The reason I've taken to this one is this is the one with all the menu for 3D printing and modelling. Thank you very much.